Integration services include several kinds of containers. The first is the task host container. Integration services generates one of these kinds of containers anytime you add a single task to the control flow designer. You configure the task host container indirectly when you configure any individual control flow task. Then there's a sequence container. A sequence container connects several tasks in order to share variable scope and common failure and success precedence constraints, as well as lets you set properties on a large group of controls. It can be very convenient to be able to set multiple properties or the properties for multiple tasks all in one fell swoop. Then there's a for loop container. You can use a for loop container to run as long as a condition evaluates to true, something you define, some expression that you define. The for loop container is similar to the while and for loops that are common in many programming languages. Then there's also a for each loop container. This container repeatedly executes a set of tasks based on the contents of some collection of objects or data, such as the files in a folder or the items in an array, for example, within a variable. And then there's a grouping container. This is a container that you can use exclusively for organizing the visual design of a package. It functions as a great way to keep your complex control flows organized. You can hide sets of tasks when you're not directly working on them. Now, all of these containers share a number of properties. The idea here is that you can manipulate the behavior of all tasks as a single unit within the for each loop, the for loop, and the sequence containers. And you do that by configuring these common properties. Now, only those three containers have properties that you can directly set. You can set the properties of the task host container when you set the properties of the task it encapsulates. Okay, so there's a few interesting properties that are shared amongst these containers. The first is delay validation. By default, Integration Services validates the configuration of the container when it's loaded into memory. A problem often arises when an earlier task in a package creates an object that a later task depends on. So this delay validation setting lets you delay validation, as the name suggests, on the later task until the task executes at runtime, when presumably all the objects that it depends on exist in memory. So that can be very handy in a number of scenarios. Disable lets you disable the execution of the entire container. This is useful for debugging a package when you only want to run certain tasks until you know that they're working correctly. Then you can disable them as a group and then work on another part of the package until you have the whole package complete. So that can save a lot of time and a lot of work, really simplify things. The maximum error count. This sets the number of errors that Integration Services is going to allow before failing the container. The default value for this property is 1, but you can set it to a different value if your package can handle a certain number of errors within the data or other kind of errors that might arise during execution. The fail package on failure property causes the package to fail on the first error if this property is set to true. If any errors exist within the container, then the entire container reports failure. Then there's transaction option, and the transaction option specifies which transaction setting is going to be used during execution of the container. And you can set this to supported, not supported, and required. And I'll be getting into the details of transactions a little bit later in this course. And then finally, there's another property that's related to transactions called the isolation level. And this indicates the transaction isolation level of the container. And it's pretty much all the same as how transactions work within, again, the core SQL Server database engine. Okay, so that's a high-level view of the containers that are available. Now I want to start diving down into some of the details of these individual containers. And the first one that I want to talk about is the task host container. This container is unique among all the containers in that it can only contain a single task, and Integration Services creates one of these containers automatically for each task that you add to the control flow. You don't need to directly set the task host container's properties, as you can with other containers in integration services. But instead, for the task host container, you set the properties of the task that it contains through the tasks dialog boxes. The other interesting thing about this is that you can't see it on the control flow designer. Okay, so this all seems a little bit strange, right? An invisible container for every task that you get whether you want it or not. Well, yeah, integration services uses this container to provide the task with variables and event handlers. Now, since you won't normally need to deal with task host containers, I'm not going to discuss them any further in this course. But it's good to know that they're there and providing services to your tasks. And there's some very esoteric situations where you may have to be concerned with the task host container, but that's going to be a pretty rare scenario. Okay, so now let's talk about the sequence container. The sequence container defines a subset of a package's control flow tasks. And it lets you subdivide a package into smaller pieces or smaller units. Now you can use a sequence container in a lot of different ways to make building and using a package easier. And some examples include doing things like constraining the scope of a variable to just the container and its tasks. This can avoid problems with name collisions when other tasks use a variable with the same name, but they're really two different variables. Another thing you can do with a sequence container is to set properties on several tasks at once by setting the properties on the container. You can essentially include as many tasks as you want in any container, including the sequence container. And so this can be pretty efficient to be able to set properties on those tasks as a group. You can still set the individual properties on a task, but this is a great way to at least get a starting configuration or starting state for a group of controls. And then you can also set precedence constraints that require a number of tasks to execute in any order. Maybe you have 10 tasks that you individually, those 10 tasks that you don't care what order they execute in. But so that all those 10 tasks complete successfully before some other control flow task executes. So you can start to get the impression that there's some very sophisticated things that you can do with the sequence container, particularly in order to manage the relationships and particularly the precedence constraints between groups of tasks and other subsequent tasks. And then you can also group tasks so that you can disable the entire group, either for testing during package development or when a group of tasks is no longer needed in a complex package. Things change. Sometimes a set of tasks no longer apply, but you're not really ready to delete them, or maybe it's just too much work to delete them and reset all the precedence constraints. Well, you can use a sequence container to disable all of those tasks so they don't execute. And then you can also use a transaction for a set of tasks rather than across all tasks in a package. Okay, so here shows a simple example of a sequence container on a control flow. The container contains two tasks, a script task and a file system task. Neither of these tasks are going to execute until script task 1, which is a precedence for the container, until script task 1 executes. And it has to execute successfully. It's the green precedence constraint arrow. And then once script task 1 executes successfully, then the sequence container task will execute more or less simultaneously. But that's only because I don't have a precedence constraint between script task 2 and the file system task. I certainly could have one, in which case they would execute sequentially. All right, then both of those contained tasks have to execute successfully before the execute sequel task executes on the right side of that figure. All right, so this is just one of many possible configurations that you can use with a sequence container. Now, notice that in the figure there's no direct connection to or from either of the contained tasks to any tasks outside of the container. You can't make that kind of direct connection. So I couldn't do a direct connection from script task 2 to the execute sequel task. All of the connections to tasks outside the container has to be using the precedence constraint that comes out of the sequence container, not the individual tasks. But if you do try to do that, such as do a precedence constraint from the file system task to the execute SQL task, you'll get this error. Cannot create connector, cannot connect the executables from different containers. Okay, a little bit misleading error message, but it really does say what the problem is. All right, another thing about sequence containers is that you can nest them. But really, once you get beyond more than, say, 1 or 2 levels, it becomes pretty awkward to work with the containers within the designer. And by the way, don't let the sequence part of the name confuse you. There's really nothing particularly sequential about this container, other than you're likely to have tasks that have precedence constraints defined between them, and then to the sequence container and from the sequence container to external tasks. Okay, so don't get caught up in the name.